Hello everyone, welcome back to the channel. Now in this video we are going to check if the tree that we are creating, right, if it's a valid binary search tree or not. Now for valid binary search tree, what is the condition? The left node value should be less than the root node value and the right node value should be greater than the root node value. Okay, so we are going to do the same comparison, and we are going to do this also using recursion. So let's create this method. This is going to return a boolean value. Now for this one, what do we need? We need a recursive method that will take the root node, okay, and also what is the minimum and maximum value for it. So let's create that method. Is valid BST. It is going to take the root node. It is going to take one of the minimum value, and then for another argument it is going to take the maximum value. Now these are some random values. Okay, now as we go ahead in the recursive method, we are going to do this comparison with the actual values as well. Let me show you that. So this is your method which is returning a boolean value. This is your root, this is the min value, this is the max value. Now let's talk about the conditions. So if root is equal to null, we are going to return true. Okay, because we are checking for validate binary search tree, and if root is null there is no problem telling that it is true. Okay, now what do we need? Now we need one more condition. If the value of your root node is less than the min value, or the value of your root node is greater than the max value, that means it is not a valid binary search tree, right? And we will return false there itself. Else, if this is not true, that means your root value is correct, right? In that case, you're supposed to check for the left side and right side of the tree. How do you do that? Just run this method again with the correct values. That is, first we are going to check for root dot left child. The minimum value would be same, no change in the minimum value, but the max value will change. That will become root dot value minus 1. And same comparison we are going to do for the right child as well, where the minimum value will be root dot value plus 1 till the max value, and that's it. You are done with the implementation. So this method will tell us there are multiple ways to do this implementation. First of all, okay, this is not the only way. You can directly, without even passing this minimum or max, you can do the comparison with every single iteration. You can just check if the root value is greater than its left child value, or lesser than its right child value. You can do that comparison, and that you can call recursively. So there are so many ways to do it. This is just one of the implementation where we are checking if root is equal to null, we are returning true. We are checking if it is not following the rule for binary search tree, we are returning false. And as long as it follows the condition, we will return true. So let's run this program and see if we are. So currently the tree that we are passing, right, this is the valid binary search tree. So we are supposed to get true, and we are getting true. If you want to get the false value, you can do some swapping in between, and you can check if you are getting the false value or not. So this implementation working fine. So that's all as part of this video. We still have to learn few more things, okay, only for the basics. There are so many things to learn for advanced stuff, but still for basic we are going to cover like 1-2 more things, and then we'll move ahead with some new topics. That's all as part of this video. See you in the next one. May the source be with you.